In the last video, we left off with this idea of an orbital as being the location, or the electron cloud rather, as being the location, possible location of electrons. And so now we're going to kind of look at how to define the location of these electrons a little bit more precisely. So Schrodinger's equation placed limits on the energies that an electron can have. The mathematical representation of those energies we call orbitals. So orbitals can have different sizes and different shapes and even different orientations. So in order to distinguish between orbitals, we have a set of what we call quantum numbers to help identify an electron's position and location. And so quantum numbers specify the properties of the atomic orbitals and the electrons in those orbitals. It is incredibly important that you remember that no two electrons ever can have the exact same four quantum numbers. They can have 3 out of the 4 the same, but never all 4 of them. It's kind of like if you go to like a basketball or football game, not here at Glenville, but a professional one, let's say. You get a ticket. Your ticket tells you which gate you go in, maybe the section that your seat is in, a row, and a seat number. And so no other ticket can have those same 4 parts to it, because if it did, then there'd be 2 of you trying to sit in the exact same seat. And so that's kind of the way to think about these quantum numbers and electrons, is that no 2 electrons can occupy the same seat. And so we're going to take a look at these 4 different quantum numbers and what they tell us, and then we will do some more work with them tomorrow. So the principal quantum number is symbolized by the letter N, and it designates the principal or main energy level occupied by an electron. So the possible values of N are 1, 2, 3, 4, up to 7. There's up to 7 possible energy levels. N1 is located closest to the nucleus, where N7 would be the furthest away. As N increases, so does the distance from the nucleus. Basically, these are the same as Bohr's energy levels. And it says that no more than 1 electron can occupy a given energy level. Sorry, make sure it's more than 1 electron can occupy a given energy level. But the specific number of electrons that can be held in each energy level depends on the actual value of N. So think of it as the further away from the nucleus you get, the bigger the distance around your energy level. And so it can hold more and more electrons as the size increases. Your second quantum number, this is quantum number 2, is called the angular momentum quantum number. That's symbolized by the letter L, and it indicates the shape of your orbital. So an orbital shape splits the energy principal level into 1 or more energy sublevels. And so when N equals 1, there is 1 possible sublevel. When N equals 2, there are 2 possible sublevels. So then when N equals 3, 4, 5, there would be 3, 4, or 5 possible sublevels. So usually, in order to figure out your angular momentum number, you can use this little formula right here. Your angular momentum number equals N, so your principal energy level, minus 1. And so this chart is kind of handy. When your principal energy level is 1, there's 1 possible sublevel, per this rule right here. And then your possible angular momentum numbers would be 0, because 1 minus 1 equals 0. And so sometimes these sublevels will get designated with letters. And so if your sublevel is 0, the letter that corresponds to 0 is S. I guess it's right here. So this 1S, the 1 out front, tells you your energy level. And then the S tells you your angular momentum, or the shape of your sublevel. With n equals 2, there's 2 possible sublevels, and so your angular momentum numbers are 0 and 1. And so just like in the previous one, if you have 0, you have an S sublevel. If you have a 1, it indicates a P sublevel. Down to 3, the new one here is an angular momentum number of 2, and the number 2 corresponds to the D sublevel. If n equals 4, we can have 4 possible sublevels. That gives your angular momentum numbers as either 0, 1, 2, or now 3. And now we have possibility of 4S, 4P, 4D, and now our new sublevel shape is F. The magnetic quantum number is symbolized by the letter M with a subscript L, and indicates the orientation of the orbital around the nucleus. And so when we look at their shapes, if you have a p orbital, its shape is a sphere. If you have an s sublevel, we have dumbbell shape. And then D and F have super complex, and there's a lot of potential orientations. So the larger the value of n, the larger the corresponding s value would be. So like if n equals 1, your s orbital would be very small. N equals 2, your s orbital, a sphere, would get a little bit bigger, and so on. So here's a couple examples. Here are your s sublevels up here. Notice how the sphere gets a little bit bigger as the principal energy level also increases. Then we have your P sublevels, and so this is what I mean by the dumbbell shape. Kind of looks like a figure 8, I guess. And notice that they just have different orientations. And so we have this first one laying along the z-axis. The second one is along the x-axis, and then the py is on the y-axis. And then these last two images, this one shows you your possible shapes for your D sublevels, and then your F sublevels are in green. So possible magnetic numbers for your M, you can either have what we call a -1, a 0, or a +1. Oh, sorry, that's not. That's your P's, not your S's. We'll start here. So your possible values, we'll start with S. So your possible value for your S magnetic number is 0. That's it. Then we go out from either side, and now with our P sublevels, there are 3 possible numbers for the 3 different orientations. So we can go either -1, 0, or +1. So those are your 3 possibilities. Maybe I'll keep it color-coded here with the red. For your P sublevels. Then you can see that your D sublevel has 1, 2, 3, 4, 5 possible shapes. So then we can add the -2 and the positive 2. Now, all 5 of these numbers, -2, -1, 0, +1, +2, are your possible orientations for your D sublevels. Then your F sublevel has 7 possible shapes, and so we have the -3 all the way up to a +3. And now this whole range would encompass your possible magnetic numbers for your F sublevels. The last quantum number, and probably my favorite one, is the spin quantum number. It's symbolized by the letter MS and indicates the direction of the electron spin. So every electron is spinning kind of like the Earth spins on its axis. And there's only 2 possible values. You can have +1/2 or -1/2. And each orbital, regardless of shape or orientation, can only hold a maximum of 2 electrons. And the electrons in the same orbital must have opposite spins. So this is the big one here to remember, that if you know one electron in that orbital has a +1/2, then you know the second one has to be a -1/2. So when we look at this all put together in a nice little table, we can see our first quantum number, the principal energy quantum number, N. Then we have the allowable sublevels, and that corresponds to the number of orbitals per sublevel, which is your angular momentum, so the L. And so remember that when there's one orbital, then it's an S, and S equals 0, and P equals 1, 0, 1, D equals 2, and then F equals 3. So these blue numbers right here are your angular momentum numbers. Then we have the number of orbitals per energy level, and this is where we did the different shapes. And so with this S sublevel, there's only one possibility of shape, and so there's can only hold 2 electrons because there's only one orbital. Whereas with our second energy level, we now have 2 or up to 4 orbitals per energy level, since P has those 3 different shapes or 3 different orientations, and this is just the sphere. So we have a total of 4 orbitals, and each orbital can hold 2. So this first orbital holds 2 electrons, and these 3 each hold 2, so 3 times 2 gives us 6. And then when we add these together, that second energy level can hold a total of 8 electrons. Looking at our third energy level, we can see that there's 9 possible orbitals, from the 5 from the D, 3 from the P, so 5 and 3 is 8, plus the 1 from the S gives us 9. And each of these can hold 2 electrons. 3 times 2 is 6, 5 times 2 is 10. So the third energy level can hold a maximum of 18 electrons, 10 plus 6 plus 2. Lastly, when we look at the fourth energy level, we can now add that F sublevel. There are 7 possible orientations to that F sublevel, and so now we can get up to 14 more electrons, and when we add that all together for a grand total of 32 electrons in the fourth energy level. The total number of allowable orbitals in each principal energy level is equal to n squared. And so you can see that when n is 1, 1 squared gives us 1, and that's 1 possible orbital. In our second energy level, n squared is 4, and that's where we get this 4 from, and so on down the line. Then the number of electrons that can exist in a given principal energy level is equal to 2n squared, if you don't want to go through and do all these math components.